Hello everyone. This video would focus on isosceles triangle theorem, and this is the first part. Before we go over these three examples that we have on this slide, let's go over the isosceles triangle theorem. We remember that an isosceles triangle is a triangle with two equal sides. So looking at this triangle that we have right here, side AB and side BC have been marked with this tick mark right here. This tick mark tells us that these two sides are equal or they are congruent. So then we can go ahead and say that this triangle that we have here is an example of an isosceles triangle. Now, what is an isosceles triangle theorem? This theorem states that if two sides of a triangle are congruent, then the angles opposite to these sides are also congruent. So I'm just going to go ahead and write that down here. So looking at this triangle, we have side AB and side BC. Again, these two sides are congruent. The tick marks tells us that. We can go ahead and say that the angle across from AB, which is angle C, and the angle across from BC, which is angle A, both of these angles are congruent. That means they are equal. So that we can go ahead and say that if AB is congruent to BC. So if these two sides are congruent, then we can go ahead and say that angle AB, opposite to AB, is angle C. So angle C is congruent to angle A. Now let's have the converse of this theorem. The converse of the isosceles triangle theorem states that if two angles of a triangle are congruent, then the sides opposite to these angles are also congruent. So I'm just going to go ahead and write that down here. Okay, so looking at this triangle right here, if our angle A is congruent to that of angle C, so if both of these angles are congruent, then we can go ahead and say that our BC, that's the side across from A, and AB, that's the side across from C, would also be congruent. So we're just doing it the other way around so that we can go ahead and write this in a statement. If that's going to be angle A is congruent to angle C, then we have opposite to angle A is BC. So line segment BC is congruent to the one opposite to angle C is side AB. So this is the isosceles triangle theorem. Okay, so let's go over the first example here. So we're supposed to determine the measure of angle T. Looking at the picture right here, these two sides are equal. This means that the angle across from these two sides, that means angle P is equal to angle T. So we can go ahead and write that down. Again, that is based on the isosceles triangle theorem. So that is angle T is equal to angle P, because again, these are the base angles and they're equal to each other. So then we can go ahead and say that both T and P would be equal to 51 degrees since our P is 51. So we can go ahead and write angle T is 51 degrees. Now let's move on to the next example. So in this example, we're supposed to determine the length of side AR. So AR means from A going to R. Now, we can notice that both of these angles, R and E, are congruent to each other. So this tick mark here tells us that they are congruent. That means that the side across from E and the side across from R would be equal. So that means our measure for AR would also be 13, because then again, these two angles are congruent. So the side opposite from them would also be congruent. So that we can go ahead and say that our AR is 13. Now let's move on to the next example. So in this example, we're supposed to determine the measures of x and y. Please notice that these two sides right here are congruent. The tick mark is telling us that. This means that our x and our y would also be equal each other, so that we can go ahead and determine the value for these two x and y. Now, please remember that the sum of all the measures of the angles inside a triangle, that is the angle sum theorem, should always be equal to 180. So that we can go ahead and write the equation right here. So we have 84, that's the first angle, plus the second angle, which is x, plus the third angle is y. All of these three, 84, x, and y, should be equal to 180 degrees. Now, we remember that our x is equal to y because, again, that is based on the isosceles triangle theorem. So I'm just going to go ahead and write that note right here. So we have x is equal to y. So that we can go ahead and rewrite this equation, because we cannot solve for x or y because there are two variables in an equation. It has to be one variable only. So that we can go ahead and rewrite this as 84 plus, since we say that our x is equal to y, so that we can just write that as x, plus change this y to x, and that is equal to 180. Again, please remember that both x and y are equal. That's the reason why I had to use the substitution method for this, so that we can go ahead and simplify this to be, that's going to be 84 plus 2x equals 180. So that we go ahead and subtract 84 from both sides because we want to solve for x. So that's minus 84 on the other side as well. So that we can go ahead and cross the 84 out. We're left with 2x is equal to 180 minus 84 is 96. And then we're going to divide both sides by 2. Divide this by 2 here so we can cross the 2 out. We're left with x is equal to 48. So this is the value of the x right there. So I can go ahead and fill this up. The value for this again is 48 degrees. Now, since we say that our x is equal to our y, so that we go ahead and say that our y is also 48 degrees. And this makes sense because if we put in the 48 here. So if this was 48 and this is also 48 right here. And if we add 84 plus 48 plus 48, the total would be 180 degrees, which is the sum of all the measures inside a triangle. Now let's move on to the next example. Okay, look at the figure on the left and fill in the blanks below. So there are two triangles here. So we have triangle KMH and the other triangle is MHL. So there's two of them, but then we also have a big triangle. That's the whole thing. But in order that we are not confused and we're not overwhelmed with all of these sides that we have right here, it is important that we cover one of the triangles so we can just focus one after the other. So I will cover this other triangle right here so that we can go ahead and fill this first blank in. So I covered the other one so we're not overwhelmed. So we have angle K. So that corner right there, angle K is congruent to angle blank. So we need to figure out what is this blank right here. So if we don't cover this, others are get overwhelmed. Like, which of these angles are we going to pick? So again, we cover one isosceles triangle from the other, so we're not overwhelmed. So angle H, since both sides here are equal based on the isosceles triangle theorem, the angle across from them would also be equal. So angle K was opposite to this side and angle H is opposite to this side, so that we can go ahead and say that angle K is actually congruent to angle H. Now let's have the next one. So we have angle HML. So angle HML is this corner right here. So this part right there. So angle HML is congruent to blank. So we cover the other triangle here so that we're not overwhelmed again. So that we go ahead and say that angle HML is congruent to angle HLM. So that's going to be angle HLM. Because again, based on the isosceles triangle theorem, if the two sides are equal, then the angle across from them would also be equal. That means these two angles here are congruent. Now let's move on to the next example. Look at the figure on the left and fill in the blanks below. So we have side WB is right here. So we are looking at this isosceles triangle on the left. So I can cover, again, so we're not overwhelmed, I'll cover the other one right there. So we have these two angles, that's angle W and angle A, are congruent. This means that the side across from them would also be congruent. So WB is congruent to AB. So that's going to be side WB is congruent to side AB, because again, they are across from two angles that are congruent. That is based on the isosceles triangle theorem. Now we're looking for AX. AX is on the other triangle, so I can go ahead and cover the other triangle here. Again, the purpose for that is so we are not overwhelmed with all of the triangles that are in the picture. So AX is this side right here, and these two angles are congruent. The tick mark is telling us that, so that we can go ahead and say that AX is across from B. So then AB is across from X, where both B and X angles are equal. So AX is actually congruent to AB. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!